We know a few different ways we can double check that, obviously. And so we could do that, if you're solving this on your own and you wanted to double check, by all means. But let's see if we can write that a little better. Y of t equals c sub 1. We throw that part in with our solutions. Don't forget that. E to the lambda sub 1t. So e to the 2t multiplied by its corresponding eigenvector x sub 1. So 3, negative 1. Plus c sub 2 e to the lambda 2. So that would be e to the 4t times its corresponding eigenvector, negative 1, 1. Okay, now this is the part where I definitely want to get this into a nice, easier matrix form, because don't forget, we have an initial value problem here. And so I'm going to go ahead and say y is equal to, we're going to do our fundamental matrix here. So it looks like I have 3e to the 2t when I do my multiplication here, minus e to the 4t when I do that here to get row 1. Here, if I do my multiplication, I have negative e to the 2t here plus e to the 4t, and I've specifically left out, because I'm going to put them into their own matrix here, C1, C2. Okay, because remember that y is equal to psi, our fundamental matrix, times c, our constant matrix there. And in order to solve this initial value problem, and I'll just bring it down here, we had y of 0 is equal to 1, 1. Okay. What we've done, the easiest way to do this is by using the fact that if I evaluate y of 0, right, and plug in 0 all the places where I have a t there, that is equal to, yes, that fundamental evaluated at 0 times c, y of 0 being this, sorry. So I'll plug that into the left-hand side of my equation. I'll evaluate my fundamental matrix with t equals 0, and I'm going to solve for c. An option here for you is to use a little bit of our matrix, I guess, identities or knowledge here. And I find the inverse of that fundamental matrix multiplied by y of 0. That is option number 1. Okay, so using our property of inverse matrices and finding the inverse matrix there. This case, I would say that's a pretty good suggestion, just because this is a 2x2. It's pretty easy to find the inverse of psi, our psi matrix here. The other option would be to do this in a augmented matrix. So if you took y of 0 and you augmented it with y of 0 there. Did I say psi or y? I meant psi of 0 here, and you augment it with y of 0 there. If you do some row operations and then you solve there, it's essentially solving for C1, C2 when you do that. So option number 2 here is a little reduced echelon form to solve that matrix equation. All right. So that's just kind of a quick review of that. I'm going to go ahead and find psi of 0 here, which is going to look like, why did I put, I'm looking at my notes, I'm sorry. If I evaluate this at 0, I should get 3. I have written down negative 3, and I'm not quite sure why. I'll come back to that. So let's see, because 3e to the 0, it's just 3. And then we get a negative 1 here. We should get a negative 1 here and a positive 1 there. Okay. I may be looking at my notes where I found the inverse. I'm not quite sure. All right. So we are going to go ahead and solve for C here. So let's go ahead and find the inverse. We're going to need the determinant of this. So it looks like I have 3 minus, we get a positive 1 there, so 1/2. And then we switch these and we make our other elements negative. So we flip-flop 1 and 3. Gosh, now I am not knowing if I'm remembering that right. This is making for an excellent video. Shoot. So yeah, oh my gosh, why can't I? You're probably all watching this and screaming at it right now, and I apologize for that. I said that that would be the easiest option, and now here I am. I can't even remember now that I'm under fire. All right, well. All right. Well, I just looked it up to make sure, and I believe this is what we get here. So my hunch was right. I got a little nervous because I was recording your video here and I thought I was doing it wrong. But it looks like for our inverse of our fundamental matrix, we do, in fact, get this. There we go. Okay, so we're going to take that. We're going to multiply it by C. And the idea is that's going to give us our C1 and C2. So we take our inverse of our fundamental matrix times C. I'm sorry, I said that wrong. To find C, we're going to take it and multiply it by y of 0, our initial values. All right. So it looks like for our first element here, 1/2 times 1 plus 1/2 times 1 gives us 1. And then we have 1/2 times 1 plus 3/2 times 1, which is 4/2 or 2. And if you got something different, let me know. In my notes, I mean, it does give one of those as a slightly different sign, but I don't know if that's because I had a different sign value for my fundamental matrix here. I'm not seeing an issue right now with how I did it, but that doesn't mean that there wasn't something that I did incorrectly. So I'm just going to kind of zoom out on this. I'm going to bring it up here for my final answer. For y of t, I'm going to go back to this format that I used right here and go ahead and multiply by C1, C2. So I had 3 e to the 2t minus e to the 4t. I really wish my brother and my cousin would stop texting TikToks back and forth. It's driving me nuts. So I'm going to disconnect my phone. I'm sorry that you had to hear all of the updates from my annoying family members. All right. So let's go ahead and do our multiplication, get y into a non-matrix multiplication scenario here by just doing our multiplication. So we should have 3 e to the 2t minus 2 e to the 4t. Not like terms, so we leave it just like that. And then it looks like we get negative e to the 2t and then plus 2e to the 4t. Again, not like terms, so we can just leave them there. All right, so there is my final answer for y, initial value problem and all. And sorry that this has to be in 2 videos, that it was so long, but the next one hopefully will be a little bit shorter for you since it's just one 3x3 example.